Lab number 8, designing a 4-bit adder. 4-bit adder means it can add two numbers that has 4 bits. That means like this. Previously, we have added like this, right? 1 plus 1 is equal to what? 1, 0, right? This was all 1-bit number. So this is A and this is B. So both of them are 1 bit. But now we will be designing an adder that can add 4 bits like this. So your A has 4 bits and your B has 4 bits. So it can add these. Okay. Today we will be designing this circuit. Okay. How? At first, what are the objectives? To successfully use a symbol, user symbol in schematic. That means we already made one user symbol in our lab number 7. So we will be using that symbol in this lab to construct a 4-bit adder. So we'll be designing or constructing a 4-bit adder today to check the functionality of the design using simulation with built-in simulator. That means whether our adder is working or not, we will be checking that functionality. To generate the layout design, okay, this is not needed now. We'll do that later when our lab number 4, 5, and 6 will be done. Okay, now what are we going to do today? 4-bit adder. At first, we have to understand how the logic works. Number 1, let's say our A is this one. That means A3, A2, A1, and A0. Our B is this one. That means B3, B2, B1, and B0. Right? So these are the numbers we will be adding. So what we have to do? At first, you do not have anything in your hand. So you add A0 and B0. Your result will be S0, that means sum 0, and you will have something in your hand that is carry out. That carry out will go to the next place. That means A1, B1 in place of A1, B1. So you have to add C0, A1, B1. 3 things. The result will be S1. Okay, and you might have something in your hand that is called C1. That C1 will go to the next place. That means with A2 and B2. So C1 plus A2 plus B2. You have what? You have S2 as the result, and you have C2 as a number in your hand. That means carry. This carry will go to the next place. That means C2. The C2, A3, B3 will be added. The result will be S3. And something will be in your hand that is called C3. C3 will go to the next place. Since next place do not have anything, okay? Since the next place do not have anything, so it will directly go to the result. So let's do an example. Let's do some addition here. 1, 1. No, let's give some space. So 4, 1. Now 1, 1, 0, 1. So we will add these two numbers. Let's say this is our A and this is our B. Okay. Now add 1 plus 1. What is the result?
0.
Not, no, in binary.
0, 1.
1, 0, right?
Yeah.
So your result is 1, 0. Here
Yes,
0 is the sum and 1 is what? Carry. So 0 will be here.
Yes.
Okay. And what will be the 1? Where this 1 will go?
Carry.
Top.
Next, right? Next place. Next place means, okay, let's use this number using a different color. This one will go where?
On top, sir.
On top of the next place.
Yes.
Okay. Now you have to add 1 plus 1 plus 0. What is your result?
0, 1.
2. That means 1, 0.
Yes.
Not 0, 1. Do not say 0, 1. Let's say 1, 0.
1, 0.
1 plus 1 plus 0. That means 2. 2 means 1, 0. So here again, 0 will be your result. Let's give another color. And your carry will be 1. This 1 will go where? Next place, here. So you have 1 plus 1 plus 1. What is your result? 3. 3 means what? 1, 1.
1 1.
So this one will be here, and next one.
Carry.
So okay, I'm going to use this color here. This carry will go where?
Next.
Next place here. So again 1 plus 1 plus 1. What is your result?
1 3.
3. That is 1 1. So 1 will be here, and let's say this is your carry. This carry will go where? Next
Yes.
place here, right?
Yes.
Yes, sir.
Okay. Since you do not have anything here and here, so you do not have to add. This thing will directly go here as a result. So what is your result now?
1 1 1 0 0.
This is your result of 1 1 1 0 0. Got my point?
Yes, sir.
Okay. Now, very importantly, look at this. How many bits you have to add at the first place?
2.
2, right?
Yes.
So you can use half adder. Half adder has 2 inputs. You can use half adder here, or you can use a full adder. By what? By how? By considering there is a predefined 0 here. By considering this space is 0. So now you have how many inputs? 1,
3.
1, 1, 3. So you can use full adder. Why should I use full adder? We will explain this thing later in our next lab. Okay? We will not use half adder, although the half adder should be recommended. We will not use half adder, okay? But half adder is recommended. So we use full adder. So 1 full adder. Next one. Here we have to use what? Another full adder.
Full.
Here
Full adder.
another full
Also
adder.
same. Alright.
Here another full adder, right?
Yes.
Do
Sir.
we need any full adder here or any adder here?
No.
No, because it is direct, right? It is directly going to the result. So how many full adder we
Yes,
need?
sir.
4.
4. Since it is 4-bit adder, that's why we need 4 adders. Got my point?
Yes, sir.
Okay. Now we will go to the design. So this is the primary design that you have to follow. This one is for A0, B0. That means the first stage. Okay. Next one for second bit. This is for third bit. This is for fourth bit. Now here you will have A0, B0. The sum will be the sum. That means A0. The carry will go to the next bit, right? As carry in. Look at this. Here, at the first bit, you do not have any carry. So we will consider that as 0. Can you see it is ground? Can you see there is a ground?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So we will consider this as a 0. So 1 plus 1 plus 0, what is the result? Okay, let's say this is 1 1. This is 1 0. This is 1 1. This is 1 1. That was the example that we have done already, right?
Yeah.
Okay. Now what will be the result?
1 1 0 0, sir. Result.
1 1 means 1 0. This will be 1. This will
Yeah.
be 0. This 0 is the result. So this 1 will go to the next place, that is here. So 1 plus 0 plus 1. What is the result?
It will be again 0.
Again 1 0, right?
1
Yes, sir.
0.
This 0 will go there here. This 1 will go to the next place here.
1
So 1
1
plus 1 plus 1. What is the result?
1 1
1
1
1.
0.
So this 1 will go here as a result.
Yes.
This 1 will go to the next place as a carry. So 1 plus 1 plus 1.
1
What is
1
the
1.
result? 1 1.
1 1.
This
Yeah.
1 will go to the result, and this result, that means this carry out, will directly go to the result. So what is the result?
1 1
plus
1
1 1 1 0 0. See, that was the result previously we got.
Yes, sir.
Okay. Now we'll go to the detailed schematic. This one. Okay, today we will be making this circuit. Done? Hello?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Now you see how I am going to design it. This is the software we are going to use. DSCH, the bigger one. Double click. Okay, previously we made a symbol, right? Which one is that symbol? We made a symbol, right? From line number 7, we made a symbol. This one.
Yes, sir.
We made a symbol, right?
Yes, sir.
Okay. Let's say this is the symbol. So full header 25 or full header 26, okay, whatever. So this symbol will be used. So how many full header we need?
4.
4. So I'm going to copy it. Copy. Okay. This is the copy. So 1, 2, 3, 4. This is our A0, A1, A2, and A3. So we need 4 buttons. This is A, and A. Double click. I'm going to rename A3, A2, A1, A0. Now I'm going to copy these for B. B, B, B. Okay? You got it? This is our A, this is our B. So where our this B0 will go? B0 will go the B of the last adder. Got the point? Where our A0 will go? A0 will go to the last adders A. Okay? Where the B1 will go? B1 will go here. Where our A1 will go? The A. Where our B2 will go?
D.
The second order.
Where our A2 will go?
A.
Second order A.
Where our B3 will go?
D.
First order B.
What about A3? Understood the design?
Yes, sir.
Okay. Now, at the last, that means the A0, B0, that one. Okay, let's write. This is our 0 number bit, 1 number bit, 2 number bit. This is our 3 number bit. Okay. Here, what should we give? At the beginning,
Ground.
yes, ground, right? Who
Yes,
said
sir.
that?
Me, Mahmoud, sir.
Mahmoud. At first, we do not have anything. That means we have to give ground. Got my point?
Yes, sir.
Okay.
Yes, sir.
I'm giving the ground here. Okay, by the way, before that, let's bring some LEDs. First one will be called S0. Next one, S1. Next one, S2.
Two.
S3 and S4. Okay. Now this will be grounded. Look at this here. After addition, you will have a carry, you will have a sum. The sum will be the result, right?
Yes, sir.
What will be the carry? Where the carry will go?
Next.
Next place. That means next place carry in. Like this, right?
Yes, sir.
Okay. This one. Again same. Same. Understood?
Yes, sir.
Yes, sir.
Let's check whether our result is all right or not. What was our result previously?
111
111 0
00.
Okay, let's check. So run it. So at first 1111, that means this one, that is our A. Next one will be 1101.
01.
So what is our result?
Yes, correct. The same.
11100. You got the result, right?
Yes, sir.
Yes.
Yes, sir.
Do you have the computer right now?
Yes, sir.
I'm going to pause the recording and I'm going to give you 10 minutes of time. All of you do it and I will check your video. Okay?
What we will do, sir?
You will make it. Mahmoud,
Yes, sir.
Omar,
Yes, sir.
Yasin.
Yes, sir.
Okay, you do it. Okay?
Same design, sir.
Okay.
Yeah?
Can you
Planning.
repeat? What do you say?
I said you do it. You practice it. Right now.
In software or in hard?
This software we don't have, sir.
You don't have the software?
No,
No,
sir.
sir.
The software is not working.
Yeah. Also, me, it's not working, sir. Software.
Okay, right now I'm going to give you the
Yes.
software.
Okay.
Pause the- So computer cannot do the subtraction, A minus B. Now we are doing the lab number 9, that is designing a 4-bit subtractor. We will convert our previous 4-bit adder into 4-bit subtractor. Okay? But the main problem is computer cannot do this simple A minus B operation. What it can do, it will convert this minus B into what? Plus B bar plus 1. Okay? So minus B can be replaced by plus B bar plus 1. Now this is an addition. Your computer or our computer can do the addition. Got my point? This is called 2's complement. So what do I mean by that? I'm going to show you something. Now if we want to subtract 1, if we want to do the subtraction, what is the result? Normal subtraction. 1 minus 1 is equal to what? 0. 1 minus 0. What is the result? Hey. Hello. Hello.
Sir, yes, sir. 1
1 minus 1. 1 minus 1. Result
One.
is 0. 1 minus 0.
And
1, sir.
1
1.
minus 0.
1 minus 1.
0.
So 1 minus 1.
0.
0.
Zero.
So this is the result, right?
Yes, sir.
Okay. But computer cannot do the subtraction. Okay. What it does, does the 2's complement. That means A minus B. It will do A plus B bar plus 1. That means A will remain as A. So our 1111 will remain as 1111. It will not be changed. But our minus B will be what? B bar plus 1. Okay, let's convert this B into B bar. How? your 1 will become 0. Your 0 will become 1.
1,
Your 1 will become 0.
0,
Your 1 will become 0.
0.
So B bar means all the bits will be
Yes,
changed.
sir.
Now we have one more 1. Can you see that? This 1 will be at the first place. Because if I ask you to 139 plus 1, that is this 1 will be at this place or this place or this place. Which place? This place, right?
Yes, sir.
If I say 139
Yes.
plus 1, you will add the 1 at the last place. So this is how if I ask you
Yes.
to add 1, so where you will put the 1? Here, 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 or here?
First one.
Okay, this one, right?
Last digit.
That's correct. Now, so if I add, now by the way, now it is addition. So if I add, what is the result? 1 plus 1 plus 0.
1.
Result is 1, 0, right?
Yes, sir.
So 0 will be here,
There was
One.
0.
while
Very.
your 1 will be go.
Next.
1 will go to the next place. What is the result now?
1, 1, 1. Swap around.
1.
3. That means 1, 1. So
Yeah.
the last one is here. What about the 1 in your hand?
Next.
Next. So 1 plus 1 plus 0. Result is 1, 0, right?
1, 0.
So 0 will be here.
1.
0.
So
Yeah.
your
Carry
1
one.
will go to the next place.
Yes.
So 1 plus 1 plus 0.
0.
Yes.
1.
1, 0, right?
Yes, sir.
So 0 will be here. And you have what?
1.
You
1.
have 1. That 1, where it will go?
Next.
On the top.
Next place. Now, if I consider these 1 at the first place of our result, see, our result is not matched. Our result has some problem. The last 4 bit and the last 4 bit are correct. Can you see that?
Yeah.
But if I take these and place it here, our result is incorrect. So we cannot consider this carry as our first bit. We have to ignore it. Got my point?
Yes, sir.
Yes,
We have
sir.
to ignore the last bit, last carry. We have to ignore it. If we ignore it, see the result?
Same.
We do the subtraction by means of addition. This is how your computer do. So how can you do it? Oh, by the way, how you will add at 1? How you will add 1 at 1? You will add 1 1 at the first adder as carry in. That's why I told you to use full adder. Remember, if I use half adder, then I only had 2 inputs. If I use full adder, I have 3 inputs. Previously, this input was grounded, right?
Yes, sir.
Now we will not ground it. We will give a 1. Okay?
Okay,
Okay,
sir.
everyone? Okay. I'm going to clear it. Now I'm going to go to the screen. Now I want to convert these into a subtractor. So I need NOT gates. So I need some space to put the NOT gates. This is a NOT gate. I want to place it here. Copy. 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 Or you can actually place them like this. Okay? That's point. So now they become B bar. This one will be what? Grounded or 1? This will be grounded or 1?
1, sir.
1. 1 means 5 volt. What is the 5 volt? Here is the 5 volt. VCC. Okay?
Yes, sir.
Now, if I give some example, so 1, 1, 1, 1, minus, oh, by the way, last bit should be ignored, right?
Yes, sir.
Last result should be ignored. Ignore means we do not need any output for that bit. That is not needed. Now I'm going to run. So 1, 1, 1, 1, 1, 1, 0, 1. What is the result? 0, 0?
Be 0, 0, 1, 0.
0, 1, 0.
Now I want you to apply these. Okay, what is that? I want to use a display. It's a display. Okay. Now I want you to use a hex keyboard. Double click, change the key, write name A, write A, show pin names. Okay, double click, again okay. Again, I need to copy it. Double click, oh no. Double click, I want to change the name to B. No. Yes. Okay. So this is A3, A2, A1, A0, B3, B2, B1, B0. Now we have a hex input. So we do not need to click 1111 or 1001. We'll just click the hex numbers. This is a hex display. Now run. So I want to subtract 9 minus 5. What is the result?
4.
4. 9 minus 3. What is the result? What should be the result?
6.
6. Okay, here you have F. F means 15.
Yes.
15 minus 8 should be, the result should be 7.
7, yes.
Okay. Now
Yes,
the only downside, the only problem, you cannot give. Okay, you cannot give a bigger number here. That time you will have a problematic answer. The bigger number should be here. The
Okay.
smaller number should be here. Okay.
Okay, sir. Okay.
Otherwise, you will have a problem. Okay, let me show you something. If I give 5 here, and if I give 9 here, so 9 minus 5, result should be what?
Minus.
Minus
Should be minus,
4.
or
Yeah.
9 minus 5, result should be 4.
Minus
It is
4.
not 4, it is not minus. So the result is not
Yeah.
okay. Got my point?
Yes, sir.
So the result
Yes,
should be 9 minus 5. Got it?
Yes, sir.
Yes, sir.
So this is the subtraction. So next class we will be doing a circuit called adder subtractor. Can you see that?
25.
Adder subtractor. That means
Yes, sir.
we will combine the both circuits together. That will give us one circuit that can do both operations. Here, can you do addition? In this circuit, can you do addition?
No.
No. For doing addition, you have to delete all the NOT gates, right?
Yes, sir. And
Then
last
you have
one,
to
ground.
delete the VCC. You have to give a ground,
Yeah.
and you need another display,
Yes. LED.
right?
Yes, sir.
LED or whatever. Got it or not?
Solid, sir.
Okay. So again, if you need to do subtraction, you need to add all the NOT gates. Here you have to delete the ground. You have to give VCC. You have to delete one display. So you have to delete and do it again. Delete and do it again. So we do not want to do that. We want one circuit that we do not have to change. Okay? We will not change. we can do both operation in one circuit. That is called adder subtractor. We will do the thing in our next lab, in our next class. Okay?
Okay, sir.
Okay, sir.
Okay. Then we will have our lab number 10. That means in our next lab, we will do this. Then we will do this.
Okay.
Then we will go for our exam.
Inshallah.
Inshallah.
Okay, sir.
Okay. I want you to practice lab number 7 and lab number 8 very nicely. Okay?
Okay, sir.
Okay,
Okay.
sir.
The class is over. You can leave. Thank you for attending my class.
Okay, sir.